video we will see about generalized sequential pattern algorithm, which is used to extract frequent sequences from the sequential database. Generalized sequential pattern algorithm is similar to a priori algorithm, generates the candidates and tests them. Generalized sequential pattern algorithm uses a priori principle, generates the candidate and tests them, which is similar to a priori algorithm. And here in this video we will consider an example sequential database and try to generate all the possible frequent sequences. So here let us consider a sequential database, and each brace here implies a transaction within that sequence, which implies that in the first sequence we are having 5 transactions, in the third sequence we are having 4 transactions, in the fourth sequence we are having 2 transactions. So here let us try to generate frequent sequences within this database. Let us consider minimum support as 2, and initially we start with 1 length candidate sequences. We extract all the frequent 1 length sequences. Then we try to generate 2 length sequences using 1 length frequent sequences, and so on. Here length of the sequence, a sequence is 1 length sequence if it contains 1 element within it or 1 item within it. A sequence is 2 length sequence if it contains 2 items or 2 elements within it. A k length sequence contains k elements in it. Here let us see that this is the 1 length sequence possible from this sequential database. Here 1 length sequence implies that 1 element within the sequence, right? So here A is 1 element, B is 1 element, element or item. A is 1 item, B is 1 item, C, D, and so on. So these are the possible 1 length sequences from this database, and the support of these 1 length sequences are calculated here. The support of 1 length sequence A is 3. That is because A is present in sequence 1, 2 and 3. So A is present in 3 transactions. Therefore, the support of sequence A is 3. In the same way, we calculate for the support of all the 1 sequences. Here, let us consider sequence D. Sequence D is present only in sequence 2. So, support of sequence D is just 1. So, in this way, we calculate 1 length sequences. Okay, these are 1 length candidate sequences, C1. We extract L1 from this. L1 is all the frequent 1 length sequences. Okay, so except D, all the other 1 length sequences are frequent. Here, after getting 1 length sequences, we have to extract 2 length sequence. To generate 2 length candidate sequences, we have 2 things which is similar to a priori algorithm: join phase and prune phase. In this join phase, here it is given that when we have to join with L1, when we are joining L1 with L1, we need to add the item X if X is 1 length item set and Y 1 length sequence and Y is 1 length sequence. When we are combining these 2 sequences to form 2 length sequence, we have to combine in these 2 ways. That is, X present in one transaction, Y present in another transaction is one combination, and the other combination is X and Y present in the same transaction. These 2 combinations we obtain only for this generation of C2, or when we are combining L1 with L1, we get the 2 combinations for the single join. Here GSP algorithm has certain constraints to follow, but in this video we are not considering all those constraints. We are just following without any constraints how can we extract the frequent sequences in this algorithm. That is the reason why here there is some definition of contiguous, subsequence, max gap constraint and all, but we are not considering any constraint in this video. We are trying to extract frequent sequences with no constraints. We also delete candidate sequences that have any subsequence without minimum subsequence. If we apply any constraints, then we come with this condition. So if we don't have any condition, then we just go with this candidate subsequence pruning. Here this is the condition how to join L1 with L1. Here this is the L1 for this considered sequential database. From this we have to form C2, that is 2-length candidate sequences. According to this, if I have to combine AB, if I have to join this AB as length 2, I have to join in two ways. One is AB belongs to same transaction, one is AB belongs to different transactions. So here I have generated 2-length sequences A. Okay, so A is joined with B and formed AB. And here this is if there is no gap between these elements, then it implies that each element belongs to different transaction. So here A and B belongs to different transactions, and here A and B within the bracket, if I specify it, it implies that it belongs to same transaction. Here A and B belongs to single transaction. In the same way, here AC belongs to different transactions, and here AC belongs to same transaction. AB belongs to different transactions and AB within the same transaction. That is what the condition which is shown here. X and Y belongs to different transactions and XY belong to same transaction. For one join, we have to generate these two sequences. For L1, only for L1 this is done. And one more thing you have to keep in mind is, for different transactions, A belongs to one transaction, B belongs to one transaction. When this is the case, then the sequence AB is not equal to the sequence BA. And when it is considered in the same transaction, when A and B are within the same transaction, then no matter what the order is, both are same. Exactly, these two sequences are same. That is the main point. And here with the A, I have generated all the sequences. So let us see for all B, C, E, F, G also. Here actually I combined B with A. But one thing, I did not have the sequence B and A within the same transaction for B here. That is because B and A within the same transaction is equal to A and B, which is already generated sequence when we are generating it with A. We have generated that sequence with A. Again, if we generate the same, like if we generate B and A within the same transaction, as both the sequences are equal, it is just a duplicate candidate generation. That's it. That is the reason why we are not generating BA within the same transaction for B here. Okay, that was already generated with A. So we are not generating it back with B. Okay. In the same way for C also, BC we are not generating and CA we are not generating because within the same transaction, because CA and AC are same and CB and BC are same, which were already generated. In the same way we have generated for E, for F and for G. So these are the 2-length sequences with the frequent 1-length sequences. These are the possible 2-length sequences from this 1-length sequence. So now we calculate support for these sequences, that is here AB. If you observe here how to calculate the support, A and B present in two different transactions. Okay, so let us check that. A is present in this transaction, but there is no B present in a different transaction after A. So this sequence 1 is not considered for the support of AB. And here A is present in this transaction. Next B is present in this transaction. There are different transactions and A is appeared first, then B has appeared. So this sequence is contributing to the support of this AB. And here also sequence 3, A is present in one transaction and B is present in another transaction and A present before B. So this is also contributing to support of AB. Because these two sequences contains this AB, the support of AB sequence is 2. In this we are not at all having A in sequence 4. And next, if I consider AB within the same transaction. So here if you see this, sequence 1 has AB within the same transaction. In sequence 2, here AB is present within the same transaction. Because of that, these two sequences are contributing to the support of this AB within the same transaction. So in this manner we calculate support for each sequence. So here is all the two length possible candidate sequences, and we have calculated support for all the two length sequences. This condition is only for L1. For all the other L2, L3 and so on, here is the procedure to join. Okay, so here in L2 with L2, for this example I'm just calculating C3 now. So I'm having L2 with L2. We can join two sequences S1 and S2 if by dropping the first item of S1, the subsequence obtained must be same as the subsequent obtained by dropping the last element of S2. So this is the condition that which two sequences can be joined. Okay, this is the condition for which two sequences has to be joined. And here, when two sequences are eligible to join, how to join those two sequences? So I will explain this conditions with an example here. Here this is the two length frequent sequences L2. Okay, now let us start that example. Here let me consider sequence AB and sequence AC. Can I join these two sequences? The first element of S1 and the last element of S2. If I remove these two elements, then the subsequence of S1 and subsequence of S2 must be same. Then only we can join those two sequences. Here the subsequence is B and here the subsequence is A. Both are not at all equal. So the sequence AB and sequence AC cannot be joined in this way. If you see this next example, AB and BE. Here let us remove S first item in S1 and last item in S2. If you see the subsequence obtained after removals, here S1 contains B and S2 contains B, which is exactly equal. So we can join this. These two sequences are eligible to join. So we can join this as ABE. Now here E is joined as a separate transaction. A is in one transaction, B is in one transaction and E is in one transaction. Why? Because of in S2 if we see B is in single transaction and E is in another transaction. So if we observe S2, B is in one transaction and E is in one transaction. That is the reason why when we combine these two sequences, we maintain the same, that B should be in one transaction and E should be in one transaction. Okay. So let us also consider this example. The first element of S1 and last element of S2 is removed and the subsequence obtained by S1 after removal and S2 after removal is same. We have obtained B. So we can combine these two sequences. Okay. And now after joining we got this sequence, three length sequence. And here if you observe, A and B are within the same transaction and E is in another transaction. This is because from S2, B and E must be in different transactions. So B and E is in different transactions. But from S1, A and B are in same transaction. So from S1, A and B are in same transaction. In this way we combine the sequences. Okay. According to S2, E should be in another transaction, and according to S1, A and B should be in same transaction. Okay. So let us consider one more example here. From S1 remove first item B and from S2 remove the last item, and both the subsequences are equal, F and F. So I can combine these two sequences. The resulting sequence, three length sequence is BFG, where FG belongs to single transaction. From S2, F and G belongs to same transaction. That is the reason why F and G are in same transaction even after joining. From S1, B and F should be in different transactions. So after joining also B and F are in different transactions. So in this way we are joining the sequences. Hope you understand how to join two sequences, and these are applicable for any length sequence from two length. All the joins are done based on these rules. Whether two sequences can join or not is based on the subsequences of S1 and S2 are equal or not, and how to join them after their eligibility is based on S1 and S2, how they were previously in LK-1. In the same way they are obtained in CK, and using these we generate 3 length sequences from 2 length. And one more thing here, after generating 3 length sequences we can prune the candidate sequences. If you see ABE, generate 2 length subsequences of this 3 length sequence. That is, for ABE, subsequences are AB, AE and BE. All these 3 must be present in L2. AB is present in L2, AE is present in L2 and BE is also present in L2. So this is a valid candidate sequence, ABE. Fortunately, all the sequences are valid candidate sequences except this one, CFG. If you consider this candidate sequence and form the 2 length subsets, then the subsets are CF, CG and FG. CF, according to this, C and F are belongs to different transactions. So here also CF belongs to different transactions. Here CG belongs to different transactions. So here also different transactions. And here FG belongs to same transaction. So the subset also contains that FG belongs to same transaction. So these are the 3 subsets, and you have to check whether all these 3 subsets are present in L2. If we check that CF is present and FG is present, but CG is not frequent. When CG is not frequent, at least one subset is not frequent, then this is not a frequent sequence and this cannot be used as a candidate sequence. So we can eliminate this sequence directly without even checking the support. And only this sequence subset has infrequent sequence, but all the others are frequent. Here we have calculated the 3 length sequence support. For example, let me tell about. I'll just show how to calculate support for one candidate sequence. Okay, so let me consider BFG. Here B is in one transaction and FG must be present in single transaction. Sequence 1 is contributing to the support of BFG. But here if you see B is present and F is present but G is not present in this sequence. So this is not contributing. Next, if you see here sequence 3, B is present in one transaction and FG are present in other transactions and B present before FG. Even order of the occurrence is also important. So this is contributing for the support of this sequence and this is also contributing for the support of this sequence. So the support of this sequence is 3. We have already seen the rules for what sequences can be joined and how to join those sequences when we are generating C3. In the same way those rules are used here also to generate C4. By using those rules we can generate, with those rules we are generating C4 now. Here if you observe, when we remove A here from sequence 1 and E from sequence 2, last element, then BF, the remaining subsequence is BF, and here also the remaining subsequence is BF. Exactly equal subsequences. So we can combine and form ABFE. But here if you see these two sequences, ABF and BGE, here if I remove A and E, the subsequence from S1 is BF and subsequence from S2 is BG. Though B is common, but these two subsequences are not exactly equal. That is the reason why we are not combining these two sequences. So based on the rules, we can form these 4 candidate sequences for length 4 and the support of those sequences are this. Here we can have only 3 frequent sequences, and if you observe clearly, we cannot generate 5 length candidate sequence from this 4 length sequence because this is not frequent. We cannot use it anymore, and we are having only 3 sequences. If I remove the first item in the S1 A and the last item E in the S2, if this is S1 and this is S2, then in S1 the subsequence is BF, in S2 the subsequence is AFG, which is not equal. So I cannot combine these two sequences. Okay, if we consider this one and this one, then if we remove A and E, the subsequence we obtain is BFE and BFG. Even then both are not equal. So we just cannot combine these two also, cannot join these two also. And here if you consider these two sequences, if I remove A and E, FGA is the subsequence obtained and BFG is the subsequence obtained from this. So even these two are not equal, so I cannot combine these two also. So I have checked all the possible joins for these and none are satisfying. So we cannot generate the 5 length sequence. As we cannot generate, here we stop this. These are the sequences which are frequent from the considered database, and these are what we obtained, and this is how we generate frequent sequences using GSP. And here in this video we did not consider any constraints, any timing constraints or any other constraints. This is how we can generate frequent sequences using GSP algorithm. Thanks for watching. I hope you have learned something. Thank you.